Hello, my name is Oleksandr Sharko. I am a professor Kherson Maritime Academy. I present our work, building an intelligent system for managing immigration labor resources in condition of uncertainty of military action based on the Markov chains. A possibility of using elements of the theory discrete Markov chains for modeling the kinetic and immigration of the able-bodied population caused by military operation has been studied. A database and conceptual model of the immigration resources management system have been developed. In contrast to the traditional use of Markov chains, time is not argument of managing immigration labor resources, but a discrete sequence of states. Misuse of their labor resources, mainly auxiliary workers in the fields of the construction, work in the service sectors, cleaning the territory, security, etc. Uneven evacuation at the associated variable quantitative compositions of the resident population caused by the emergence and during of the hospitalized. In the difference in the time component, continuous time associated with organization, movement abroad, discrete time caused by the offensive, the seizure of the territories, the destruction of objects of visual use, different age composition of the able-bodied population because mainly women with children and pensioners were let through the bodies. The task managing the dynamic of the processes represented in slide number 4. The dynamic of the process is determined by two aspects: the initial probability distribution and the matrix of transition probabilities. The equation describes the initial probability distribution. The matrix transition probabilities is a contains the transition probability vectors. On slide number 5, we represented the formalization of the primary measures for the measurement of immigration resources The state statistics of Ukraine estimates the number of labor immigrators at 1.3 million people and experienced estimate 2 million people up to 4 million people. Disagreements arise because of different data collection methods. Probabilistic estimate of the dynamic influence of the main factors are present in slide number 6. Was obtained by proceeding the available information from the UNICEF and Institute of Demography and National Academic Science of Ukraine, official the UN Military Commissariat. In slide number 7, we represent conditional probabilities of the evacuation decision process. In slide number 8, we represent the transition probability matrix. In slide number 9, we represent steps by building a Markov chains. The first step by building a system of management of immigration research is to establish the availability of your own means for moving in your territory characterized by the parameter V1. An orientated graph of Markov chains for building intelligent system for managing immigration labor research in the face of uncertainty in military operation is shown in slide 10. Since the system's transition from one state to another occurs the indefinite intervals, the occurrence of which is due to the imagined military situation and the accumulation of the appropriate amongst the innovative and other research. It has a consistent Markov process is discrete time. The present or graph helps to indefine the most important point in the construction of the categories of the target function and to make informed discussion to strengthen the positions of the which to focus. This graph can serve as a simulation model of influence and intelligent system for managing immigration labor resources under the uncertainty in military operation. Conclusion. Markov chains reveal the existence of the relationship between the probability distribution of the main control parameters in a visual form and various levels. The use of Markov chains allows predicting the results of future actions generative and predict situation without the use of mathematical algorithm. The advantage of the developed intelligence system for managing immigration resources is the ability to model and regulate the process of making appropriate decisions in real time and adjust the system to any information situation. Thank you for your attention.